Instead of putting a number into a function, like we usually do, we are going to put a function into a function. Composition of functions are pretty simple, okay? I have two functions. I have g of x, I have h of x. Basically, what it means is, I'll give you an example. Number 3, this is number 3. We first going to take the number 3, put it into g of x, and that answer we get, we're going to take it and put it into h of x. That's pretty much it. I'll give an example. So we put 3 into g of x, we got the answer 8. Now we're going to put 8, the answer, into h of x. And that's it. That is the composition of g and h. Okay? This is it. That's what it's all about. But this is a pretty long way of writing it. I mean, in order for me to tell you what I was about to do, I had to say like what, 3 sentences? That's pretty long. There's a much faster way of writing this whole process, and it's written like this. Basically, what this is saying is that first apply g to x, like we did, and then apply h to that. So this one was first, and then this one is second. Does the order matter? Yes, the order matters. If g was here and h was there, it would mean a different thing. I'll show you. So if it was like this, it would first mean apply h and then apply g. But now this raises a good question. If we switched around like this, would we still get the answer 64? Or would we get a different answer? In other words, does order matter? Let's try it and see. So first h of x. Now we're going to do g of x. Well, no, it doesn't. It doesn't work out. The answer is 14. What was the answer in our previous example? It was 64. So what are we saying? This swapped around, they are not equal. Okay, the order does matter. It does matter very much. Now, this is a pretty long way of writing it. Okay, why do we have to write it like this? I mean, I first have to write h of x and then I have to write g. Is there a shorter way? Yes, there is. And it's written like this. This means the same thing as this. This is this. Because what are we doing? We first take in the x, the number, we apply h to it, and then that h of x is the answer. Then we apply g to it. That's what composition of functions is all about. Now here's another way to think about it. I go to a shop, I buy a sack of oranges, then I give them to you, then you peel the oranges, then you give them to your grandma because she has lost her teeth. The oranges first went through me, then they went through you, then they got to your grandma. All right? That's basically the composition of functions. Why can't your grandma peel it for herself? I don't know, man. Maybe she lost the grip or something. That's not important. The point is, the sack went through me, then through you, then got to your grandma. I showed you an example with 2 functions. Can you do this composition thing with 3? Now we're doing 3 functions. I know this kind of looks intimidating. Don't worry. It's pretty simple, okay? h, g, f, f, g, h. Now remember what I said earlier. The order does matter. So first we're going to take the x, put it into h, get the answer. Take that answer, put it into g, get the answer. Take that answer, put it into f. That's our answer. So let's do it. Another way of writing this is like this. X, that's our number. Then we're going to apply h to it. Then we're going to apply g to that h. Then we're going to apply gf to everything, to g. So let's test it out. Let's take a number, a simple number like 1, and let's try it out. Let's test 1. Put in 1 here, we get 1 plus 1, that's 2. All right. Put 2 in here, we get 2 times 2, that's 4. All right. Put 4 in here, we get 4 minus 3. What's the answer? 1. So the answer to this whole thing here is 1. That's pretty much it. Now I'm sorry, because I'm about to break your heart. It's not as simple as I made it. This thing gets pretty complicated because of domain. Okay, now we're trying to find the composition of f, g, and h. Okay, now I'm gonna erase this for now because I don't have enough space, but we're going in this direction. So we're starting with h, g, and f. Okay, remember that. So look at this. what is the domain for h of x? For example, where is h of x defined? Where is it valid? Where is it not allowed to go? And all this stuff. Well, h of x can go anywhere. Think about it. You can put in any number there. 1,000, 1,000,000, 0, -4, -1,000,000, whatever. You're always going to get an answer. There's always going to be a value, y value, for any number you put in there. So the domain for this is from -infinity to positive infinity, okay? All numbers are allowed for this guy. Now, let's move on to this man, okay? This is a square root. Remember, you cannot have a square root of a negative number. So what's the domain for this? What's the limitation? What's the restriction, okay? All the x number must be greater than or equal to 0. Why must it be greater than 0? Because it's going to be a positive number. You can square root a positive number. Why can it be equal to 0? Because if it's equal to 0, you can get the square root of 0. The square root of 0 is 0. Okay, let me take these off. Now let's move on to this guy. What is going to make f of x invalid? If you put in 3 there, we're going to get 3 minus 3. We're going to divide by 0. You can never divide by 0. So for this guy, x cannot be 3. If it's 3, we're going to get division by 0. Okay, so this one didn't have a domain. No, it doesn't have a domain, sorry. It does not have a restriction. It just has a domain. Negative infinity to infinity. This one, everything must be greater than or equal to 0. This one, it's everything but 3. Okay, now that you get that, let me remove that. Okay, I'll try and keep this. I don't have enough space. I'm so sorry. Okay, let me remove it for now. It will make sense later. All right. Now that you understand it, okay? So let's start over here. Let's start with a number like 1. Let me put 1 here. If you put 1 in here, what do we get? We get 1 minus 2. What's 1 minus 2? That's -1. Okay, no problem. Now take -1 and put it in here. You can't. It's going to crash. You cannot have anything less than 0, like we said. Okay? So now do you see how if it can be valid for one function, but it's not valid for the second one? It can be valid for both functions, but not valid for the third one. Now here's an example. Okay? I'm going to give an example. Let's try the number 11. Try the number 11. 11 minus 2, well, that's 10, that's 9. So it works for this one, 11 minus 2. No problem. We get 9. Then what's the square root of 9? It's 3. So it works for this one, no problem. But hey, we said x cannot be 3. So it doesn't work for this one. So you see again, it can work for the first two, but crash on the last one. So this is where domain comes in. This is where domain is really important, okay? So how do we approach this? How do we work with such ugly looking functions? Here's how we do it, all right? We work from the inside out. Never, please never work from the outside in. Work from the inside out, all right? Start with go out. This is the last one, this is the first one. Start, go out. All right, let's go. So we're going to take h of x, put it into g of x. So if we take x minus 2 and we replace it with this, what are we going to get? We're going to get the square root x minus 2. Does it make sense? Yes, it does make sense. It does make sense because x minus 2, that was h of x. And then we put it into the square root, which was g of x. All right. So we've done the composition of h and g. And we got this. Okay. Now, this is g of x. Now, the answer to this, what would make this invalid? Well, if this is equal to 3. If g of x is equal to 3, we're going to crash. So what do? Let's solve this, all right? So we're going to square each side, and square cancels with the square root. We're going to have x minus 2 is equal to 9. Move the 2 to the other side, we have x equals 11. What the hell does this mean? X equals 11. It means that in all of the answers you can put anywhere here, x cannot be 11. Now check this out. Check this out, okay? Take this 11. All right, x cannot be 11, sorry. X cannot be 11, all right? If you take this 11, put it in here. What's 11 minus 3? Well, 10, 9, 8, 8. So you get 1 over 8. That's not a problem, all right? Now take 11 and put it in here. What's the square root of 11? I don't know, but there's no problem with that. 11 is a positive number, all right? Now take 11 and put it in here. What's 11 minus 2? It's 9. There's no problem. So why are we saying x cannot be 11 when clearly there's no problem? That's because you're working from the outside in. That's what I'm saying to you. Do not work from the outside in. You're going to end up with things like this where it looks like it's working, but it's not working. Now, instead of working from the outside in, let's work from the inside out and see what we get. So 11 minus 2, what do we get? We get 9. What's the square root of 9? It's 3. So you're going to end up with a 3 here. 3 minus 3. You see what's happening here. Okay? So you need to be careful when you're working with the domain of these stuff. Okay? Extremely careful. So, in other words, what are we saying? What's the domain for this whole? So, if you have to draw the composition, so the composition, all right, it says this is what it looks like. So the domain for this composition will look like this, all right? So we have a number line. That's our number line, all right? We have 11 somewhere here, and we have 2 somewhere here. Where do I get these numbers? 2 and 11? Well, remember the first time what we said. We said that if we have x here, all right, we take h of x, you put it in here, you're going to end up with this. You're going to end up with x minus 2, and this has to be greater than or equal to 0. Okay, if you move the 2 over, you're going to get x greater than or equal to 0. That's how I got the 2. That's where I get the 2 from. And for the 11, remember what we did. We took this, we put it in here, all right, and then we got this. And this can't be equal to 3. So then we solved that, then we got our 11. So we got our values, our important values. Now let's check them out. So anything to the left of 2 does not work. Why? Because x has to be greater than or equal to 2. You can try it out. Take any number less than 2. It's not going to work. It's going to crash somewhere there. Okay? So this side does not work. But it says here x can be greater than or equal to 2. So x can be all these values here because it can be greater than 2. But it cannot be equal to 11. So we're going to skip 11. And then we're going to carry on over here. So if you had to write that in interval notation, it would look like this. That's what it would look like. This is called interval notation. Now, I know this stuff looks complicated and it probably doesn't make sense to you, okay? But in order to really understand this stuff, you need to understand domain. If you need a recap on that, you can check my video over here, or you can check my description for other great YouTubers, all right? Maybe they can explain to you better. But this is basically it. This is the composition of functions. Sometimes you can get composition of functions of 2, 3, even 4 or 5 of them, okay? But as long as you understand how domain works, you're good. If I didn't make sense to you, I do apologize. I will try and do better next time. Thank you for watching.